We saw in some previous examples that sometimes when we have a rational function, the numerator or the denominator or both will be able to factor, and we might be able to rewrite or simplify a function. So let's go ahead and look at what happens when we are able to divide out a common factor. So let's consider the function f of x equals x squared minus 5x plus 6 in the numerator, and then in the denominator let's do x squared plus x minus 12. Now then, we can rewrite this particular function. We can factor the numerator, so let's go ahead and rewrite this function factoring both the numerator and the denominator. The numerator can factor out as x minus 3 times x minus 2, and the denominator will factor out as x minus 3 times x plus 4. And so that's what each of those factors out to. Now then, we do have an x minus 3 in both the numerator and the denominator. However, before we start just crossing things out, we need to make sure that we know this is the function that we're given here. So we do need to go ahead and state the domain of this function. The domain, remember that the denominator cannot equal 0. So if I look, I can't have x minus 3 equal 0, which means I need to throw out 3, and then x plus 4 can't equal 0, so I need to throw out negative 4. So I need to have a domain that is x such that x does not equal negative 4 and x does not equal positive 3. That's the domain of this function, especially before we want to start canceling some things out. Now then, since the factor x minus 3 can divide out of the numerator and the denominator, we can say that f of x, our function, behaves as the function, and if I go ahead and divide these out, I can say that this is basically behaving the same way as f of x equals x minus 2 over x plus 4. Except if I were giving you this function at the start, the only thing you would have to exclude from the function is negative 4. But remember, we still also had to exclude this x equals 3. So even though this factor canceled out right here out of both the numerator and the denominator, I still have to have this restriction on my domain. So the function can behave like this, but the domain is still the set of x such that x cannot equal negative 4 and x cannot equal 3. So even though plugging 3 into this function might give me a value that doesn't look like it's undefined, remember the initial function, it is undefined if you plug 3 in. You would get 0 over 0, which is something we'll talk about in calculus. But this x equals 3 is still a restriction on the domain, even though I might be able to plug it in right here and still get a particular value.